Hello everyone, welcome to my new video. So today we are going to solve another question related to binary tree, and it is all path for a sum. So it's just an extended version for our previous question. Okay, so in the previous question we just checked like is there any path exists that give us a particular value, but in this one we have to find all the paths that is given that particular value. Suppose here the sum is 12, so we are looking for the path that will give us 12. So in this one, like 1, 7 and 4 will give us 12. Some of this like give us 12. Similarly 1, 9, 2 will give us 12. So now our answer is going to be array 1, 7, 4 and 1, 9, 2. So let's see how we can solve this question. So in the previous question, what we did, we had two base conditions. So if root equal to if root is pointing to null, then we are returning false, right? So I'm just returning. I'm returning. I think I'll add up. Just wait for some time, and the end you'll get to know like why I did this. So and the another case was one when we are checking if it's a leaf node or not. So for that, what we are doing, we are checking if root left is equal to null and root right equal to null, and then we are checking that if root value is equal to remaining sum, then we will return true. So yeah, just wait for here also. I'm not returning anything, just showing that how it's an extended version of the previous question, right? So for now, as of now, I should remove this return just to make sure that you guys don't get confused. So here the conditions are going to be same because as it's an extended version. Has path, root left, comma sum minus root value, and similar for the other one. Has path, root right, sum minus. So I think this is same as of previous one. So let's check what is different here. So for storing, so it's a 2D array. So we'll take a 2D array. You can name whatever you want to. Okay. So I'm taking a 2D array where I'm going to store this, and for this particular function I'm going to take 1D array, and this function is going to be void. So if root is null, so I'm not going to return anything, it's just return. So now we'll push our node into this array. So array dot push our first node, that is going to be root value. So as we check, if root value is equal to sum, and we have this array, this whole array, suppose now the root value is 2, and that is going to be 9 minus 1 is 10 and 12 minus 10 is 2. Now this 2 and this leaf nodes 2, they are same, so it means this is the path. So for that one, we'll push this array to our 2D array. So in this 2D array, we'll push this array. So our else condition is going to remain same. We have to do this, and after that, after pushing the value, here, like we pushed the value. Now we have to move to our previous parent, right? So we'll remove that last value, array dot pop. This is a whole condition, and we'll print this 2D array. So why exactly I popped out in the last? So suppose this one 5. Suppose you want a sum of 8, and we are moving only for this path. So here the sum is going to be 1, 2, 3 and 4, and that is going to be 7. So that's not. So but in the last we push this 4. That is not a part of an array, because we don't need this 4, because we need 5 and we don't need this 4. So what we'll do, we'll pop this out. Now it moved to this part. Now we have 5. So this is our array that we needed. So that's why we are popping and pushing. So once it's done, we'll pop this one out, then this one out, then move to this one. So with this we'll get our all the paths. This is the current node, and we need a current path, so we can store, and in this vector we are going to return all the paths we have. So this is our first. If the current node is pointing to null, then we just simply return it, and in the starting we pushed our node just to check like is it a part of a path or not. So here we are checking our second condition, like if it's a leaf node, this is a leaf node condition, and if the last node is equal to the remaining sum. So if it's satisfying all the conditions, then we are putting our current path, like this vector current path that we have, this one, into our all paths, the 2D vector. Or if it's not this condition, then what we are doing, we move to the left part, and same, we are subtracting the sum of that particular node, and for right also, and in the end we are just removing that last element that we pushed in for the new combination, just to check that that is path or not. If it is, then we will push it in this part. That's all guys. Thank you for watching the video.